Today's lesson is chapters 8.3 to 8.7. There's a lot of content to cover, but they're all related. It's basically the same concept applied to different shapes. So today we're studying surface area and volume, which hopefully you have some experience with. Okay, so remember the surface area is the amount of area to cover a 3D shape, and the volume is the space inside of a 3D shape. So prisms are 3D objects with two parallel bases. So a base is the top part or the top face, and then the bottom face of the prism. Okay, so the base is again the top and bottom, and then the body are the lateral faces. Lateral face is the body of the 3D shape. So again, prisms, how we can distinguish a prism from a pyramid is that prisms have parallel bases. So this base is parallel to this base. So this is a rectangular prism, and this is a triangular prism. Okay, so triangular prism, the bases are triangles, and they're still parallel to each other, and that's why it's considered a prism. Calculate the surface area of each prism. So what we're going to do is we're going to add together the areas of each base and lateral surface. Remember that all of the formulas that you'll need for volume and surface area can be found on this formula sheet, which I referenced yesterday. So yesterday we were using the front page, which is all of our perimeter formulas and all of our area formulas. Today, we're going to be using the second side, which is all of our surface area formulas for 3D objects and volume formulas. So the surface area of a rectangular prism is 2 times width times height plus length times width plus length times height. Okay, again, I'm getting all of my formulas from the formula sheet. Surface area is equal to 2. Now I'm going to use square brackets because I'm going to use double brackets here in this line. So my width is 6.5 and my height is 12.2. My length is 8.1. Okay, so I'm going to simplify these two, then these two, then these two. Following BEDMAS, saying the multiplication comes before addition. Okay, now I'm going to add everything inside of the brackets together and then multiply by 2. Okay, and remember that surface area has the same units as area. Okay, so it is essentially area of each face added together. So it still has those squared units. Here's a triangular prism. So the bases are still triangles, even though this prism is just sort of flipped on its side, but the bases are always parallel to each other, okay? So this is not the base because it's not parallel to any other face. This is the base, and this is the base. They're parallel faces. Okay, so we're trying to find the surface area of this triangular prism. So remember, surface area just means area of all the sides. So I'm trying to find, let's work on this one. I want to find the area of this face. Area of a triangle is base times height over 2. So base times height divided by 2. And this would be the same value. Okay. And then this face is a rectangle, and we know that area of a rectangle is length times width. Okay, so 6 times 3. And this side right here is also a rectangle, so length times width again. So it would be 4 times 6. Now we have this last face that we need to find. Again, it's a rectangle, so the area is going to be length times width. So we have our length, but our width, we actually don't know what it is. So we have to use the Pythagorean theorem to find side C, which would then be the width of this rectangle here. Okay, so over here, I'm going to use Pythagorean theorem to find C. Here's C, side C. So I'm starting off with my Pythagorean theorem formula. Okay, and then plugging in the 2 legs for A and B, and I'm solving for C. Okay, so I've now found out that the side is actually 5 centimeters. Okay, next let's find the area of our triangular faces. Okay. Okay, lastly, we're going to find the surface area, or the total surface area. Of our triangular prism. So our surface area is the area of the 3 rectangles plus the area of the base times 2, because there's 2 bases. Okay, so this rectangle right here, so that's 6 times 5 centimeters. So 6 times 5 plus this rectangle here is 4 by 6. Plus this rectangle here, which is 3 by 6. Plus the area of the base times 2. So 2 times 6. Remember, we found the area of the triangular base. Okay, so 6 times 5 is 30. 4 times 6 is 24. 3 times 6 is 18. 2 times 6 is 12. And then adding those up, Our total surface area is 84 squared centimeters. Now, in example 2, we're going to calculate the volume of each prism. So the volume of a rectangular prism is length times width times height. Okay, so length, width, height. And for volume, our units are cubed. Okay, so here's our triangular base prism. We're trying to find the volume. Okay, so the volume of a triangular base prism is area of base times height. Okay, so remember, this is your base, and then this would be the height of your base. Okay, so we need to find the area of our base first. So I'm going to do that over here. So area of base, that is equal to base times height over 2. So the base times the height divided by 2. So 5.5 times 6 over 2, which is equal to 33 over 2, which is equal to 16.5 squared centimeters. Okay, so then I'm going to plug that into my total volume. So times the height now of the total prism. Next, we're going to calculate surface area and volume of pyramids. Pyramid is a polyhedron, which base is a polygon and whose faces are triangles that meet at a common vertex. Okay, so the faces are all triangles, and then they meet at this point here. And then they have a base, which is this. All right, so let's find the surface area of this pyramid. Okay, so the surface area of a pyramid is equal to 4 times area of the triangle, because there's 4 triangles, 1, 2, 3, 4, plus area of the base, right? The base is here. We need to find the area of each triangle, and we're missing some information. Remember that the area of a triangle is base times height over 2. So if we're looking at just this triangle right here, we're given the base, but we don't actually know what the height is of this base. Okay, we're given the height of the actual pyramid, but that would not apply to the face of each side. Okay, so this height would be different than the face height. But this actually creates a right triangle. So we can actually find this side length by using the Pythagorean theorem. So this could be S that we're trying to find. So let's use the Pythagorean theorem to find S. Okay, so we know that from here to here is 8 centimeters. Okay, so then half of that would be 4. And we know that this side right here is 9 centimeters. We're trying to find S, side. Okay, so the side is 9.8 centimeters. Okay, so let's find the area then of one side triangle. So step 2, I'm going to erase this for a second. Step 2 is finding the area of triangle. So we know that area is equal to base times height over 2. Okay, so base 8 times this height, which is that side value that we just found. So 8 times 9.8 divided by 2. Okay. So since our base is a square, that means that each triangle face would have the same area. Okay. So when finding our total surface area is equal to 4. That's why we're just multiplying one triangle area by 4 because they all have the same area. So our area of our base is 8 times 8, or 8 squared, because it's a square. So now finding the volume of a prism. Okay, we're given now the side length of our prism face, but this time I don't really need that. Okay, so for the volume, that's the space that's inside of the object. Okay, so this 13 centimeters, that's the side of the prism. It's along the face. So that information doesn't really pertain to me for this question. What I do want is I want that height of the prism. So I'm going to go ahead and I'm going to create that right triangle so that we can now find the height. Okay, so that if we redrew this over here, it will look like this. So this is 13, and this is 5, half of 10. And now we're trying to find the height of our prism. So step 1, find height of, pyramid. I said prism. So I'm trying to find my height. I know that my B is 5 and that my C is 13. Okay, so the height of our pyramid is 12 centimeters. Now I can find the total volume of this pyramid. So the volume is equal to the area of the base times the height all over 3. And again, I'm getting these formulas from the formula sheet. Okay, so area of base. So this is a square base. I know that because of these ticks here. So it's 10 by 10 or 10 squared. times our height, which we just found, all over 3. Okay, so before I multiply 10 and 12 together, I have to square 10. Okay, so something to note when we are finding the surface area and volume of pyramids. So in example 4, we were finding the surface area and we needed to find side S. We needed that information in order to find the surface area. And for example 5, for volume, we needed to find side, or not side, but the height of the pyramid. Okay, so for surface area, you need side S, whereas in volume, you need the height of the pyramid. Okay, so make sure that when you're finding the surface area of a pyramid, you're not using the height value. And for volume of a pyramid, you're not using the side value. Okay, so I'm going to just write that note down here at the bottom. So side length, S, is used when finding surface area of pyramid. And the height is used when finding volume of pyramid. Okay, so make sure that when you are reading questions that you're really paying attention to the information given to you and what it's asking you to find. All right, moving on to 8.4 and 8.5, which is still working with surface area and volume, but now in a cone. All right, so here are some examples of cones. Okay, so the surface area of a cone is 4 pi rs plus pi r squared. So pi times radius times side or slant plus pi times radius squared. Okay, so remember your base is this circle here. Base area is pi r squared. And your lateral area is your body. Okay, and this is sort of the lateral view from above. So this is like the point of the cone, and you're looking down onto the cone. Okay, so that's your lateral area. Okay, and then the volume of a cone is 1/3 the volume of a cylinder. So area of a base times height over 3. Okay, and again, you can use the Pythagorean theorem to determine the height of the cone. Okay, so same thing here is make sure that when you're finding the volume, you're not using the slant or side length, you're using the height. So same idea here, you're going to have to work with Pythagorean theorem. In depending on if you're finding surface area or volume. Okay, so we're trying to find the surface area of this cone. So we need to use S. Okay, so remember to use S for side or slant when finding surface area. Okay, so we're given the height of the cone, but remember for surface area, I want the slant. Okay, and here is your right triangle. Okay, so 24 by 9, half of the diameter. And I'm trying to find S. Okay, so first off, I'm going to find S. Okay, and then step 2, find surface area. So surface area is equal to the area of the lateral surface, or the body of the cone, plus the area of the base. Okay, and remember your radius is half the diameter. And following bed mass, so I'm going to multiply 1, 2, and 3 together. 723.8 plus, so before I multiplied pi 9 together, I'm going to square it. And now I can multiply 81 by pi. Okay, now we're trying to find the volume of this cone. So remember to use height when finding volume. So you need to use the height, not the slant. So again, first we're going to have to use Pythagorean theorem to find height of the cone. Okay. So here it gives us the radius, so it's or the leg of the triangle. And we're trying to find A, so I'm just going to replace A with H because that's our height, and we know the hypotenuse is 16. Okay, and then step 2, find volume. So volume is equal to the area of the base times height all over 3. So area of a base, so the base is a circle, so that's pi r squared times height over 3. So pi, the radius is given to us, and the height we just found. Okay, using BEDMAS, I'm going to use square 10 before multiplying anything together or dividing anything together. Multiplying all of my numerators together, and then dividing it by 3, and then my units is cubed. Okay, lastly, let's practice finding volume and surface area of a sphere. Okay, and we're going to practice finding the volume and surface area of a sphere in a word problem. Okay, so below is an example, and then on the next page, it's just problems pertaining to this example. A cylindrical silo for grain storage has a hemispherical top. The cylinder has a height of 168 feet and a base radius of 6 feet. Calculate the total volume of the silo to the nearest cubic foot. Okay, so we're going to have to find the volume of the cylinder. And we need to find the volume of half a sphere. Okay, so here's my cylinder. So we need to find the volume of that. And we also have half a sphere here. Okay, and then we will add them together to get our total volume. Okay, so referencing my formula sheet, the volume of a cylinder is pi r squared h. And it gave me the radius in the word question and in the diagram. And it gave me the height in the question and in the diagram. Okay, and so I'm just rounding it because it told me to round it to the nearest cubic feet. Okay, so the volume of half a sphere. So the volume of a full sphere, again, referencing the formula sheet, is this. Okay, so finding the volume of a full sphere first. Okay, now I'm going to divide it by 2. Okay, because it's only half a sphere. So that is equal to 452 cubic feet. Okay, so our total volume total, is equal to volume of the cylinder plus volume of the half sphere. So 19,000 plus 452, which is equal to 19,452 cubic feet. The silo should be filled to no more than 80% capacity to allow for air circulation. How much grain can be put into the silo? So we found the total volume at 100% capacity. Now it's saying that it can only be at 80% capacity. So 80% in decimal form is 0.8. So I'm going to multiply my 100% capacity by 0.8, 80%. That is equal to 15,562. Therefore, 15,562 cubic feet of grain can be put in the silo. A truck with a bin measuring 6 feet by 3 by 3.5 feet delivers grain to the farm. How many truckloads would fill the silo to its recommended capacity? So we're not using the full capacity here. We're using the recommended 80% capacity. Okay. So let's find the volume of this bin. Volume of bin. So it's length times width times height, which is 6 by 3 by 3.5. Okay, so the volume of the bin that's filled with grain is 63 cubic feet. So that's one load. Okay, so how many loads do we need to fill our silo to 80% capacity? So what I'm going to do is I'm going to divide our capacity by the bin volume. So our 80% bin capacity is 15,562. And I'm going to divide that by the capacity of one bin. And that'll give me how many loads we'll need. How many bins, number of bins or number of loads. So this truck is going to have to deliver 247 of its bins in order to fill the silo at 80% capacity. Last question. It is necessary to paint the surface area of the silo. Okay, so you're painting the whole silo, not including the base. so not including the base, but everything else must be painted. 1 gallon of paint covers 36 square feet of surface area. A gallon of paint costs $40. What is the cost of paint required to give the CLO 1 coat of paint? So there's multiple steps here that we need to do. So we're painting the surface of the CLO. So this is a surface area question. Okay, so first we need to find the surface area of our half sphere. And then we need to find the surface area of our lateral cylinder. Okay, so lateral, just the body of the cylinder because we're not including the base of the cylinder. So let's find the surface area of half a sphere. So surface area is equal to 4 pi r squared, and then we're going to divide it by 2 because it's just half a sphere. Okay, squaring my 6 before multiplying and dividing everything together. Okay, and the surface area of just the body of the cylinder is equal to 2 pi RH. Okay, and again, I'm just rounding it to the nearest cubic foot. Next, let's find the total surface area to be painted. So surface area total is equal to surface area 1 plus surface area 2. 226 plus 6,333. 6,559 squared feet. Step 4. So now what we're going to do is we're going to take our total surface area and divide it by 1 gallon of paint, which covers 36 square feet. So that equals to 182. So that's actually the number of gallons of paint that you need. Okay, and then step 5, let's find the total cost. So 182 gallons of paint, and it says that each gallon of paint is $40. So that is approximately $7,289. So you're going to be spending a lot of money on paint. Therefore, it will cost approximately $7,289 to paint the CLO. All right, so that's everything on volume and surface area. There are some questions at the bottom and on other pages for you to complete before trying today's quiz. And if you have any questions, please message me.